All right, welcome back, Algebra. Let's do some quadratic word problems. We've been working with the quadratic formula. We've been working on graphing quadratic equations. Now, actually, let's put this into practice. Now, I love these problems. I actually get excited about them. Maybe I'm weird. Maybe you think I'm weird, but I think they're pretty fun. Let's look at number one. So, Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by that function, where t is the time in seconds and h is the height in feet. Well, here's what I want to look at. I want to zoom in right here on this equation. Anytime, almost any time, 99% of the time, when you see a t squared or an x squared in an equation, the awesome thing is questions are going to be the exact same. All right, and I can ignore this. It doesn't matter to me whether he is jumping off a cliff or kicking a football or launching a rocket. Doesn't matter. All I'm looking at is that equation. Now, a couple things about this equation that you're going to see all the time. First of all, the number in front of the t squared, that's going to be negative 16 because that's actually a real number. That's how fast gravity accelerates something back towards the Earth at negative 16 feet per second squared. So that's kind of cool. The number by itself at the end, the 480, that's our C value. That's the height that it starts at. So in this case, the cliff that he's jumping off of was 480 feet high. Another couple things, h of t, or sometimes you'll just see it as h, this part right here, that's going to be your height in feet, and t is going to be your time in seconds. All right, so let's look at this. Letter A. How long did it take Jason to reach his maximum height? Well, so let me draw a picture here. So Jason's on this cliff and he jumps up and he comes down and he hits the water. And I want to know his maximum height right there, that point right there. Well, this is, if we look at this, this is a parabola. And we know that the highest point on a parabola is the vertex, right? The vertex, we know how to find that. That's just negative b over 2a. So for letter A, how long did it take him to reach his maximum height? We're just finding the vertex. Negative b, let me write down a, b, and c here. A is going to be negative 16, b is going to be positive 16, and c is going to be 480. So when we go negative b, that's going to be negative 16 over 2 times a. When you put that into your calculator, you're going to get 0.5. All right, what that answer means is 0.5 seconds. It takes Jason 0.5 seconds to reach his maximum height. So letter A, I'll just write it out here to the left, 0.5 seconds. All right, letter B. What was Jason's maximum height? Well, I know it happened at 0.5 seconds, and I've got this equation up here, and in this equation, we already talked about t being your time in seconds. So just like you were making an XY table to graph it, just plug 0.5 in for t and see what you get. So pause this if you need to, but I'm going to move on. That's going to be 484. When you punch that in your calculator with 0.5 for t, it's going to be 484 feet. All right. Letter C, how high was Jason after 3 seconds? So this time our time is our time is 3. So we're going to put 3 in for t. I'm going to have to use my calculator. I don't remember what this one was. Negative 16 times 3 squared plus 16 times 3 plus 480 equals 384. Okay, so just putting 3 in for t, that's going to be 384 feet. All right, let's do another one, just like this. Number 2. If a toy rocket is launched vertically upward from ground level with an initial velocity of 128 feet per second, then its height h after t seconds is given by that equation if air resistance is neglected. All I got to do is look at that equation. All right, that's it. So, letter A. How long did it take the rocket to reach its maximum height? So we're shooting a rocket up off the ground, and it comes back down and lands, and I want to know maximum height. That's going to be the vertex, which is negative b over 2a. So up in this equation, our A value is negative 16, our B value is 128, and our C value is 0. So if I go negative B, that's going to be negative 128 over 2 times A, which is negative 16. If you put that into your calculator, negative B over 2A, that's just going to be 4. It takes him 4 seconds to reach the maximum height. What is the rocket's maximum height? Well, 4 is our time, right? So let's just plug that back in for t. If I put 4 into this equation for t right there and right there, let me see what we get. Negative 16 times 4 squared plus 128 times 4 equals what? 256 feet. 256 feet. This was 4 seconds and 256 feet. Okay, so that's the highest height he ever gets to. Negative b over 2a tells us when it happens. That was going up and coming over. That was at 4 seconds, 256 feet. So when we plug 4 seconds in for t, that's going to give us a 256. Letter C, I kind of accidentally gave you a free question here, free answer. How high was the rocket after 4 seconds? Well, we just did that. We just put 4 in there. Just so happens that that was 4 seconds was the vertex, which we already found. So that's 256 feet. All right, so that's all you have to do for this assignment. First step to find the maximum height, find the vertex, negative b over 2a. That's going to give you the time. That gives you the when it was at its maximum height. And then plug that time back in for t in that equation, and that's going to give you your maximum height. If you want to know when, like if you're given a time like 5 seconds or 2 seconds or 1 second, all you have to do is sub that into the equation for t. All right, so I'm going to stop here because I've kind of covered it all. If you need to see this again, just go back and watch this video again. Slow it down for yourself, pause it. Make sure you're working out these problems on your own with your calculator and some paper and pencil. All right, I know you can do it. Good luck.